Each device within an IP network requires a valid IP configuration. There are two ways to assign IP configuration: manual and dynamic. In the manual approach, you manually assign an IP configuration to each device individually. In the dynamic approach, you configure the DHCP service, and it provides IP configuration to all devices. If your network size is small, you can use the manual method to configure and manage IP addresses on all devices. However, if your network is large, the manual method will not work for you. Let's understand it through an example. Suppose you are a network administrator in a company that has more than 2,000 devices in its network. The company bought a new internet connection and asked you to configure all devices to use it. Depending on how you previously configured the IP configuration on all devices, this could be an easy or difficult task for you. If you manually configure the IP addresses on all devices, you need to reconfigure them. However, if you use DHCP, then you only need to change the configuration on the DHCP server. When the clients reboot or renew their IP configuration, they will automatically acquire the new IP configuration from the DHCP server. A DHCP server can provide IP configuration in three ways: static, dynamic, and automatic. In the static method, you configure an allocation table on the DHCP server. In this table, you add the MAC addresses of all clients and assign an IP configuration to each client. The DHCP server uses this table to assign IP configurations. When a client requests an IP address, the server looks up the client's MAC address in the table. If it finds a match, it returns the corresponding IP configuration. In the dynamic method, you configure a range of IP addresses on the DHCP server. The DHCP server assigns an IP configuration from the configured range to each client that requests an IP configuration. It assigns IP addresses for a defined period, known as the lease duration. The configuration remains valid until the lease expires, after which the client must obtain a new IP configuration from the server. The automatic method is similar to the dynamic method. In this method, you configure a range of IP addresses on the DHCP server, and the DHCP server assigns an IP configuration from the configured range to each client that requests an IP configuration. However, it assigns the IP configuration permanently by setting the lease duration to infinite. Once an IP configuration is assigned to a client, it remains with that client indefinitely. When a DHCP client needs an IP configuration, it connects to a DHCP server and requests it. A DHCP server contains several pre-configured IP configurations. When it receives a request from a client, it provides an IP configuration to the client from all available IP configurations. This process goes through 4 steps: discover, offer, request, and acknowledgement. Let's take an example to understand these steps. A network has 3 PCs and 2 DHCP servers. Right now, these PCs do not have any IP settings. The DHCP service is running on both servers. Now, let's see how a PC in this network gets its IP address from a DHCP server. When you turn on a PC, it first checks if it already has a valid IP address. If not, it generates a special message known as the DHCP Discover message and sends it to the local LAN segment. In this message, the source and destination addresses are set to all 0s and all 255s. Any device, whether it has a valid IP configuration or not, can use these addresses to send and receive messages in the local network. When the client sends a DHCP Discover message to the local broadcast address, every DHCP server on the network receives it. If there is more than one DHCP server, each one gets the message. A DHCP Discover message includes the client's MAC address. DHCP servers use it to assign and track the IP configuration. Depending on their configuration, multiple DHCP servers can reply to the DHCP Discover message. In reply to a DHCP Discover message, a DHCP server sends a DHCP Offer message. Since the client does not yet have an IP address, the server cannot send the offer directly. It uses the local broadcast to reply. The DHCP Offer message reaches all devices in the network. It contains an IP configuration and protocol-specific information, such as the lease duration and the client's MAC address in the client ID field. An IP configuration typically includes the client's IP address, the subnet mask for the proposed IP address, the default gateway's IP address, and the DNS server's IP address. Every device on the local network receives the DHCP offer message. Each one checks the client ID field. If a device sees its own MAC address there, it knows the message is for it. If it sees a different MAC address, it assumes the message is for someone else. The host that sent the original DHCP discover message accepts the DHCP offer message. Apart from that host, all other hosts ignore the message. Depending on the number of DHCP servers, a host may receive multiple DHCP offer messages. If a host receives multiple DHCP offer messages, it accepts only one message and tells the corresponding server with the DHCP request message that it wants to use the offered IP configuration. The DHCP server uses a unique transaction ID in its offer message. The client includes this ID in its DHCP request message. Just as devices use the client ID to determine whether a message is for them, DHCP servers use the transaction ID in the request message to determine whether their offer was accepted. If a DHCP server finds its transaction ID in the request message, it knows the client accepted its offer. If it sees another server's ID, it assumes that its offer was rejected. Besides the server whose offer has been accepted, all other servers withdraw their offer and return them to the pool of available addresses. Let's understand this process through an example. Server 1 offers the IP address 10.0.0.1 and uses TX1 as its transaction ID. Server 2 offers the IP address 192.168.0.1 and uses TX2 as the transaction ID. The client accepts the first server's offer and sends a DHCP request message to acknowledge it. When this message reaches both servers, they check the transaction ID and MAC address fields to determine whether their offer has been accepted. Server 1 sees its transaction ID and knows its offer has been accepted. Server 1 adds the offered IP address to its list of assigned addresses. Server 2 and any other servers see the transaction ID of Server 1 and assume that their offer was rejected, so they return those IP addresses to the available pool. When the DHCP server gets a request message from the client, the process reaches its final step. The server then sends a DHCP ACK message to the client. This message lets the client know that the server has received the request message and can now use the offered IP configuration. In summary, obtaining an IP configuration from a DHCP server involves 4 stages: discover, offer, request, and acknowledgement. In the first stage, the client broadcasts a DHCP discovery message to find a DHCP server. In the second stage, the DHCP server responds with a DHCP offer message that includes the lease duration for the IP configuration and the client's MAC address in response to the DHCP discovery message. In the third stage, the client accepts the offered IP configuration and sends a DHCP request message to notify the server. Finally, in the fourth stage, the DHCP server sends an acknowledgement to the client's request. That's it for this video. If you have any suggestions, comments, or feedback about this video, feel free to share them in the comments section below.